Fuel is one of the heaviest components of any aircraft. On long-haul flights, it can account for up to 1/3 of the aircraft's total takeoff weight. That's not a small variable. It's a dominant force. Now imagine placing all that weight inside the fuselage, the main body where passengers and cargo sit. Immediately, you run into three major problems. You lose valuable cargo space, you concentrate stress in one area, and you make the aircraft harder to balance. If all the weight, fuel, passengers, cargo, is concentrated in one area, the structure must be much stronger, heavier, and thicker to handle it. But if that weight is spread out efficiently, the structure can be lighter and more optimized without sacrificing strength. And this is exactly the problem engineers are trying to solve. Wings are not just for lift. They are the backbone of load distribution. By storing fuel inside the wings, engineers move a massive portion of the aircraft's weight directly to where lift is generated. This reduces bending stress on the wings and spreads forces more evenly across the entire airframe. Takeoff is one of the most demanding phases of flight. At this moment, the aircraft is at its heaviest. Engines are at full thrust, and aerodynamic forces are rapidly building. The wings are under intense pressure, not just lifting the plane, but resisting bending and flexing forces. Here's where fuel becomes more than just payload. When fuel tanks in the wings are full, they actually increase the rigidity of the wings. Think of it like reinforcing a beam. The added mass stabilizes the structure and helps distribute the total load more evenly. This added stiffness helps keep the wings level and prevents excessive flexing, especially as the aircraft accelerates down the runway. There's also a safety advantage that often goes unnoticed. Fuel stored in the wings allows for something called gravity feeding. In simple terms, fuel can flow naturally toward the engines without relying entirely on pumps. In the rare event of a system failure, this passive flow can act as a backup, keeping engines supplied when it matters most.